Welcome back. We're in Giancoli, Chapter 2, the acceleration section, questions and problems, set to problem number 4. We look at this and we got a graph here, and check it out. It's a position time graph, and this is a picture of the graph here. Somebody accidentally made little marks in the book there, I guess. Don't do that if you have a book. Anyways, construct the velocity time graph for the above position time graph. Okay, cool. So I'm going to go ahead and do that below here. And I'm going to try and keep my time axis nice and lined up with their time axis. And then I can just drop all of these times down here. And then all of the sections of my graph will line up with the above sections, which will make it nice and neat. And I'm going to make it in quadrant 1 and 4 here, because maybe the velocity is going to be positive, and sometimes maybe it's going to be negative. Looking at that graph, I've done these before, and I'm looking and realizing that, hey, yeah, it's going to be negative at some points. A lot of times it will be. So, and if you don't know, do both quadrants and you'll cover your bases here. Okay, so I'm not going to put in the numbers for velocity yet because I don't know them. All right, but let's see if I can figure them out. Now, the linear sections are going to be easy to find the velocity, right? And the person who made these marks here, I think that they were trying to do that for themselves. And check it out, about where they did that here. Yeah, it looks like it's linear up until that point. Maybe it goes a little bit beyond there. Actually, well, I don't know. Maybe it looks like it goes till here. No, because it looks like a different curve. Yeah, we'll go with that. So 10 to 15, and that's like 17 or 18. We'll call it 18. Why not? So about the 18-second mark, which is about right here, 18. It's going to be linear. And what is that? Well, we can actually calculate that because we have a 5 over here. So that's going to be a rise of 5 over 18. And so that's going to be not a nice number, right? That's going to be 5 over 18. I grab a calculator. That's like a quarter, just over a quarter. It's 0.27. So it's 0.28. It really rounds up to. So just over a quarter. I'm going to go ahead and round it to almost a quarter here. So if this is 0.25, then just above that, right about there, the velocity is constant. Well, I should make that a different color. Velocity is going to be constant to there. So that's supposed to be a horizontal line. Stick with me. So I'm going to try and graph the things that I do know for sure, and then maybe I can fill in the other things along the way. All right, now, looking at the next bit here, well, that's curved there. And right now, we don't have a good way to figure out what the velocities are if it's curved. We can figure out generally what's happening. Hey, check this out. The slope is getting steeper. I can check that out because if I draw like tangent lines, a line that goes through one point there, and so if I draw tangent lines, I can see that they're getting steeper and steeper and steeper, meaning that the velocity, right, velocity is the slope of this thing. I guess I should probably start it with that thing. Velocity is the slope of that thing. So that means the slope is getting bigger and bigger and bigger. So that means that it's going up. It's going to look something like that. Now I'm not going to be satisfied with that because I'm going to see if I can get some more numbers in here first. Okay, so I'm going to look for other linear regions where I can actually calculate this slope. And so looking at that, maybe it's linear in here. Maybe from, right, let me get rid of these tangent lines here. Maybe from, is it kind of, to me, it kind of looks like it curves like right up in here. But then it looks like maybe from here to here, maybe that kind of looks like linear there. I don't know if they meant it to be or not. But I'm going to go with that because it's an exercise to see if we know how to do this stuff or get some practice at doing that. So I'm going to kind of make up these times here. I don't know, that's 25. So that's like, I don't know, 27 maybe. And that's to 29. Yeah, sure. Well, let's say 29. And I'll put that down on the time axis there so it's a little bit clearer. So I'm just going to say that it's 27 and that's 29. So we have a 2-second gap in there. And then what are the positions here? Well, the position is, so that's 15, so that's like maybe 11, and then this one here, so it's like 14. So now the rise and run, we got a rise of 3 and a run of 2, so I got 1.5. So I go down here on my scale, And now I can see that if that's, now I got to try to make this a little bit constant here. So that's a half, 3/4, 1/4. Whew, I should have made that bigger. This will be 1.5 up there, and this will be 1, and this will be 0.5. Okay, cool. You get the idea. And so then 27 to 29, so that's like, try and line that up there, 27. Notice how it's now hopefully becoming apparent why I lined up these time values here. And so from here to here is at least approximately constant, like up there. Now, why would I go and do that? Well, check that out. Why would I go and do all that work? How does that really help me? Well, we just said that the slope here is increasing up to about here, right? It doesn't get steeper than this region. And so I know that the slope, and we're going to say that it's probably going to go up gradually there, or at a constant rate. And so now if that's true, now I know that this is going to go up at a constant rate. Now we don't actually know if it's going up at a constant rate, or maybe that curvature of that line is actually increasing. We don't actually know that. We're just kind of guessing in this case, and that's okay. We want the general idea. The idea is that the velocity is increasing here, and I can tell that because the slope sure looks like it's increasing. I can tell for sure it's increasing. Is it increasing? Is the slope increasing at a linear rate? Well, I'm guessing on that part, and that's okay. Now, then after that, we can see that the slope decreases. It gets smaller and smaller and smaller. I can check out my tangent lines to that and see that the tangent lines get smaller and smaller and smaller, all the way up to this point right there. Yeah, that's a slope of 0 right there. So that means that at this point right here, the velocity is 0. So, and that's right there. And that looks like it's 35, maybe 37. It looks like it's dead in the middle there. So I'm going to call that 37.5. And so I go back down on here and go, well, that's 37.5 right there. And so right there, I know that the velocity is going to be 0. So I can put a point there. And I know that it's slowing down. So now here's another linear section. And again, I'm making an approximation, assuming that it's slowing down at a linear rate, or this curve is changing in curvature at a linear rate. And that is okay, especially for this course, that's okay. In reality, does it always do that? Of course not. Could be some crazy shape going on in there. But in this course, we'll never see curves in our velocity time graph because, as I said, I took all the jerks out of this class, meaning that the accelerations will always be constant values. They will never be, increasing accelerations or decreasing accelerations on our AT graph, which would provide us with jerks if we were doing that. And then here, up until about here, I'm looking at this thing going, hey, oops, sorry. Get those out of there. I'm looking at this going, hey, the slope is increasing all the way about to this point that I put there. Because then after that, I'm drawing the tangent lines here, and it looks like the slope is decreasing after that. If you're in calculus, you'd say, oh, that's an inflection point there where it goes from like curving downwards to curving upwards there. And so that's at 45. It looks like, we'll call it 46. So here at 46, it's going to be, it's going to be increasing its velocity. But notice that the slope here is negative. And I don't know what those values are. So, I don't know. So, and there's no good way for us to tell right now what that is. There are other ways, but we're not going to get into that for this class. So I'm just going to put a question mark there. We'll do the bottom bit qualitative. So we got kind of a mixed graph here, which is a little bit odd, of a mixed quantitative graph with a little bit of qualitative going on here as well, because I just, we can't know. Maybe I should change the original graph so we can know. Good thing to do for some other year. So then at 46 to the question mark, we'll say down there, we know that it's going to be increasing its speed, but in the negative direction. And then similarly, afterwards, it looks like it's slowing down there. And it doesn't, at least on this graph, at 50, it doesn't look like it gets back down to 0. So I'm going to pick some other question mark value. That's question mark prime, because it's a different question mark. You could put actual value, like variable values would be a better way to do that. But it slows down to some other speed there, and it's approaching, the slope is getting closer and closer to 0. All right, that's it for this. Have a nice day. Bye.